Javelins thrown on school sports day can land any distance between 10 meters and 35 meters from the line. The most common distance is about 20 meters. Construct a triangular probability density function to model the javelin distances. Okay, so let's have a sketch to begin with. So 10, 35, most common is about 20, triangular distribution. So that would look something like this, and the base here is 25, and we know the area of the triangle needs to be 1, so half times 25 times h is equal to 1 would give us a height here of 2 over 25. So we need to work out the equation of each of these lines, but that shouldn't be a problem because we can use the calculator to help us with that. So I'd go to statistics, and then I can see the first line goes through 10, 0, and we know it also has to go through 20 and 2 25ths. And so then we can go calc, regression, linear regression, click OK on that, and that would give me 0.00008 x, take away 0.08. And we know that is with x between 10 and 20. Squashing to get it in there. That's okay. Let's just resize that because we don't really want the graph in the bottom. And we need our next one still to go through this one with the 20, but we also need it to go through 35 and 0. So we'll calc, regression, linear regression, click OK, and that will give me negative 0.053 recurring, that looks like, x plus 0.186 recurring, and that's for x between 20 and 35, and then 0 otherwise. Determine the probability of a randomly selected student throwing 28 meters correct to the nearest meter. Well, that means that they've thrown between 27.5 and 28.5. And we can do that as an integral from 27.5 to 28.5 of, and it needs to be this bit, so the negative 0.0053 recurring x plus 0.186 recurring. So what we need is the integral, which we know is in Math 2, and we've got 27.5 and 28.5, and so we have negative 0.005, and let's just put a few 3's in there, just probably don't need that many, and add 0.186, put a few more 6's in there, and we need to tell it we're integrating with respect to x. And execute, and that's 0.035. 373. Determine the mean of the javelin distances correct to 2 decimal places. Well, that's an expectation, so what we know is we're going to have the integral from 10 to 20 of x f of x plus the integral from 20 to 35 of x f of x, and of course it's a different f of x in each of those cases. Well, it is f of x, but it's a different part of the function. So we could do these separately because they never work for me very well when I try to do too much in one line. So we'll go from 10 to 20, and that would be x open bracket, and that's 0.008x, take away 0.08 dx, and integrate that one, and that gives me 6 point, well, it looks like 6.6 recurring. And then we'll do, we had this integral up here. If we copied that one, that would be a good one to copy. So let's paste it there. And let's pop an x in front of that bracket and change the limits. So the limits here need to be now 20 to 35. So let's do that. That's 15 roughly. So I'm going to say that the mean is 21.6 recurring. Students with distances in the top 5% of throws will be chosen to compete at the inter-school carnival. What is the minimum distance students need to throw in order to be chosen for the inter-school carnival? So this is the last part of the function coming down to 35. There's going to be a value here, k, such that this area is 0.05. Now you can do this by integral, but I never have much success with this type of thing on the calculator, so I'm going to do it just using the fact this is a triangle. So I'm going to say a half times the base times the height. Now to get the height, I am going to have to use the second function, so that's going to be negative 0.0053 recurring k plus 0.186 recurring, and we need that to be equal to 0.05. So I'm going to just solve for that on the calculator. So we're going to solve 0.05 equals 0.5 multiplied by 35 take away x multiplied by negative 0.005, put a few threes in there, x plus 0.18, let's put a few sixes in there, and solve. And so the only sensible answer here is the 30.67. So k is equal to 30.67.